Hi guys, welcome to this set of videos, and what we're going to do in this set of videos is they're going to follow along with the notes that come out of your textbook from Chapter 9, Section 2, and now we're going to start our discussion on the 4 different kinds of conic sections we're going to look at, starting with parabolas. So first I'm going to take just a second here to describe to you what is a conic section, where does it come from. Then we'll take a little bit of time to talk specifically about the type of conic section we're going to look at in this set of videos, which is parabolas. But before we jump into any of that, some objectives and learning targets as we go through this set of notes, things that kind of help you focus target your learning as we go through here. You're going to need to be able to write the equations of parabolas in standard form. And of course, you're going to need to be able to graph parabolas. Now, before I go any farther with those objectives in mind, if you are taking this class with me, I have already provided you with a formula sheet that has all of the formulas that you need for all 4 types of conic sections, including parabolas. It is a 1-page front and back. You'll take a look at it. It's a ton of information, but here's sort of the good news. The good news is with that formula sheet, which you don't have to memorize any of it. I've yet to meet an Algebra 2 teacher who makes their students memorize all of those formulas. It's just crazy. And now, if you've got a teacher who makes you memorize them, awesome. You're probably better off for it, but I'm not going to make you do that. Please use that formula sheet. The key to the formula sheet is this. With the formula sheet, these problems are incredibly easy to do. Without the formula sheet, if you haven't memorized the formulas, they're very, very difficult. So keep that formula sheet close by. It's been included with the notes for this particular section and all of the conic sections. And now let's talk about what are the conic sections. Well, here's the way it works. All right, so a conic section is going to be this. What you're going to do is you're going to take a double cone, all right? So we're going to take a cone on top, put them point to point with a cone on the bottom. And then what we're going to do is take different cross sections of those conics, all right? Of those conics. So when you put a cone over another cone point to point, it's a conic. And we'll take a cross section of that conic, hence why we call it a conic section. And depending on how you divide that conic will tell you what kind of shape you're going to get. Now, there are 4 different conic sections, 4 different shapes we'll get by dividing a conic that we're going to look at. We're going to start in this section with the parabola. So we're going to do parabolas first. In the next section, we'll look at circles, then ellipses, then hyperbola. And here's how you get each of those shapes from a conic section. So this plane represents how we're dividing the conic, right? So what we've got is I've got my conic shape right here. This plane represents how I'd slice that conic section, and you can pretty clearly see that right there, if you were to slice the conic section that way, oh sorry, that's my highlighter. I want the highlight in yellow, and then I want my green marker, that little line right there. If you were to take a projection of that line, that green line, a projection of that green line, and project it onto a coordinate plane, it would look exactly like a parabola. And depending on how you change the angle of how you take that slice will change the shape of what the parabola looks like, Same thing for circles, right? You can see that we just split that conic. We take that conic section, you take that projection, right? That projection right there in green, right? Which would be shine that projection onto a coordinate plane and it would be a circle. And depending on how far down that conic section will determine the size of the circle, right? You come up toward the point, that circle gets smaller. You go farther toward the base, that circle gets bigger, right? And then an ellipse is just an elongated circle, right? So you take that plane and you just slant it a little bit. Now, depending on the angle of the slant, will determine just how elongated the parabola is, and of course how high or how low you are in the conic section. There's lots of variables to adjust, and you won't have to do any of that, but you can kind of see that projection right there, if you were to take that projection and shine it onto a coordinate plane, it would have the shape of an ellipse, an elongated circle, by just slanting that plane and slicing that conic. And then finally, the last one, hyperbola, which is probably the one that you have never heard of before. The hyperbola is just taking that exact same, take that plane, slice that conic section vertically. Essentially, here's what they're going to look like. Hyperbolas are double parabolas. You can see, thanks to the projection, which would be actually, this one's a little bit tougher to see. If you were to project it, like I said, onto a coordinate plane, essentially what it's going to look like. This top part here would give you a parabola that maybe looks like that. This bottom part here would give you another parabola that looks like that, and that's an example of a hyperbola. They're two parabolas that are exactly the same in shape, just opening away from each other. They could be vertical, they could be horizontal. Anyway, so that's what the conic sections are. We're going to look at these four types of conic sections, starting with parabolas. And again, where they come from is taking these double cones, a conic, and slicing it with some plane, just taking a section of that conic, and you'll get either a parabola, a circle, an ellipse, or a hyperbola, and those are the four that we're going to look at. So let's start with a parabola. Right here on the next page, I now have everything that you need to know about parabolas. Now, we did a lot of work with parabolas in chapter 4. You're going to see a lot of that coming back here, starting with the two forms for writing the equation of a parabola. I have standard form and I have vertex form, which you'll recognize from chapter 4. Standard form is ax squared plus bx plus c, where a, b, and c are constants, but the problem with standard form is it tells you nothing about the graph of a parabola, and we talked about that in chapter 4. This is great for factoring or solving a quadratic equation, right? This form is fantastic for that, but when it comes to graphing, it really is pretty useless. But then we have this vertex form where you can find the value of a, h, and k, which represent the transformations, right? H is the horizontal shift, k is the vertical shift, a is both a reflection as well as a vertical stretch or compression, and knowing a, h, and k can tell you a lot about the graph of a parabola, so much more useful for graphing. Now, depending on the textbook that you're using, they may in that textbook call this the standard form. If that's the case, I apologize for kind of the discrepancy between what I'm calling it and what your textbook may be calling it. For now, for the sake of these videos and the notes that I'm using, I will refer to this as vertex form and this is standard form, just because that's probably what they called them back in chapter 4 or wherever parabolas are in your textbook. So I'm just going to stick with that same terminology. Anyway, here's the point. What I'm going to do in these problems is if I give you a quadratic equation, I'm going to give it to you in standard form, which is useless. It's just useless. Take a look at the formula sheet that I gave you. Find the section on parabolas. It'll be titled Equations for Parabolas, and you'll notice that all of the information, all of the formulas I've given on that formula sheet are all in vertex form. You need to know A, H, and K. So, what are you supposed to do if I give it to you in standard form? Well, you should remember from chapter 4 to go from standard form to vertex form. The way you go from standard form to vertex form is by completing the square. And so there it is. Here in chapter 9, the algebra that we're going to be doing is completing the square. Once you've completed the square and gone from standard form to vertex form, you just use the formula sheet. You now know the value of A, the value of H, the value of K, and if you take a look at that formula sheet, everything is based on the value of A, H, and K. So the algebra here in chapter 9 is completing the square. You'll need to be able to complete the square. But once you've completed the square, everything I ask you for, vertex, directrix, focus, whatever, anything I ask you for comes right off that formula sheet. And that formula sheet, everything is based on A, H, and K. So really at that point, once you know A, H, and K, it's plug and chug. I mean, it couldn't be simpler. You just follow the formula sheet, plug in what you're supposed to plug in, don't fat finger something on your calculator, and you're good. But in order to get A, H, and K, you're going to need to be able to complete the square. So we'll go over all of that here when we get to an example problem. In particular, though, let's talk about parabolas first. So here's the definition of parabolas. You should probably already be aware of this, but here's the way that a parabola works. Now, I've got a graph of a parabola for you right here. It's in blue, and what the definition tells you is this. A parabola, the way that you find the points on a parabola, like this point right over here, or this point right here, or this point right over here, right? Doesn't matter. Any point on that blue line, the way that you find it is this. The distance from the focus to that point and the distance from that point to the directrix are equal. So what that means is that this distance right here, that distance right there, and this distance right here, there, are exactly the same. The distance from the focus to that point, that distance, and the distance from that point to the directrix, that distance, are equal. They're exactly the same. The distance from the focus to that point and from that point to the directrix, those two distances are equal. They're exactly the same. That's how you find those points on a parabola. Now, there's a bunch of features here on the parabola we didn't talk about in chapter number 4 that are things I'm going to ask you to find here in this chapter. We are familiar with the focus, but again, what the focus is the focus is the point, right, that parabola wraps around. The parabola will always curve around the focus. The directrix, we just talked about what it is. It's going to be a line. We'll put it in dotted because it's not part of the graph, but that's the line that you also have to measure that distance from the directrix to the point, and those two distances have to be equal to each other. From the focus to the point and the point to the directrix, they have to be the same. There's the length of the lattice rectum. The lattice rectum is just a line. It's an imaginary line. We probably in most cases won't even graph it, but the lattice rectum has to go through the focus, and the endpoints of that line are on the parabola. And again, you can probably see where the distance formula is going to come in, right? If I give you the coordinate points of the endpoints of the lattice rectum, and you got to find the midpoint, which would be the focus. You need the midpoint formula, hence why we did the section, chapter 9, section 1, and reviewed midpoint and distance formula. And then one other thing that I want to point out to you, the vertex. The vertex is the point that the parabola has to go through, and here's what I want to point out. Please notice, you should see in the formula sheet I've given you down here, and also in the diagram, the distance from the focus to the vertex. This distance right here, from the vertex to the focus, is exactly the same distance as the distance from the vertex to the directrix, right? So those two distances are exactly the same, and the way that you find it is the value of these distances right here from the vertex to the focus or the vertex to the directrix are given by plus or minus 1 over 4A. 1 over 4A. This is how you'll find that little distance. You'd add 1 over 4A to get to the focus. You'd subtract 1 over 4A to get back down to the directrix. And you see that down here in the formula sheet. Right there, right, is the plus 1 over 4A, and right there is the minus 1 over 4A. Please notice plus 1 over 4A gives me my focus, minus the 1 over 4A gives me my directrix, right? So they're the exact same distance from the focus. You just add 1 over 4A to get to the, they're both the same distance from the vertex. You add 1 over 4A to get to the focus. You subtract 1 over 4A to get down to the directrix, or whichever direction you have to go. Again, this formula sheet, actually this is just a photocopy of the formula sheet that I put on the formula box for parabolas I put on your formula sheet. Everything you need comes from this box. You just need to know the value of A, H, and K, because you can see everything's based on A, H, and K. All right, guys, what we're going to do is we're just going to go ahead and jump into some of these problems. Again, the algebra is going to be completing the square. You need to take standard form, complete the square to get it into vertex form so that you know A, H, and K. Once you know A, H, and K, it's plug and chug. Don't fat finger something on your calculator and you should be good. Really excited to do these problems with you. I think they're a ton of fun. I absolutely love them. I can't wait to look at them with you. Head on over to the next page of the notes. I'll meet you guys there.